into we're essentially beginning coordinate geometry. So whenever we're trying to look into coordinate geometry, just as it says in the name, it's geometry of the coordinates. So you're going to be involved with a lot of graphical work and a lot of shapes on the graph. Geometric shapes on the graph, which obviously you'll have to decipher and apply whatever equations or formulas that you might study during this. Now, when we're looking into coordinate geometry, it's probably the most easiest out of all these chapters, but there is one slight, what you may call, um, difference that we're just going to, in A levels, we're just going to, raise the difficulty level. Whatever you've been taught, it's going to carry forward, but we're also going to raise the difficulty level. So first off, I need to know what is the general form of any equation, any linear equation. So general form of a linear equation. These are some formulas and rules that we'll do first. Linear equation. This is simply y is equal to mx plus c. We've known that for the longest period of time. All right. Knowing this, what's going to happen? That this equation is also referred to as the slope intercept form equation. So the slope intercept in this sort of version is also referred to as the slope intercept form equation. Why? Because if you have the slope, if you have the intercept, you can easily form an equation using y is equal to mx plus c. We already know that m is your gradient. We also know that c is your y-intercept. And we also know that your x and y are coordinates. So what's going to happen now? Your x and y are coordinates, your m is your gradient, your c is your y-intercept. That is perfectly all right. Everything is there. Now, once we have this information, you can find for any linear equation, you can form its equation by simply using the slope intercept form equation. But how do we get to the gradient and everything? Let's look at that now. So for example, first up you have gradient. We're going to go into depth. The reason why I'm not going to go into depth with gradient right now, because we're going to open it all over again when we go into differentiation. All right. The importance of this topic is such that entire coordinate geometry, it's very easy to do so individually, but sometimes what happens, the examiner sort of pairs it up or makes a composition of this topic with differentiation, with integration, or with trigonometry. So he sort of like tries to raise the difficulty level of the question. Now the gradient is determined by, first of all, the symbol for the gradient is a lowercase m, and what is going to happen is that simply your gradient is y, sorry, change in y over change in x. All right, this is the symbol is delta. The symbol right here, this is delta, and it denotes change in y and change in x, or sort of like change in everything. All right. Keeping this in mind, how do we calculate the gradient? We already know that, but we can still write it down. So it's going to be y2 minus y1 over x2 minus x1. Very basic stuff that we're going on about here. But please keep in mind that you do not mix up the proportion of this formula. The proportion of this formula is that whatever you're using first, regardless of whether you're using y1 or y2 first, whatever you're using, please make sure that the order is the same. If you use y2 first, then x2 will follow. Do not write it as y2 minus y1 over x1 minus x2. This is like a very amateur mistake, and this will give you a gradient. Similarly, your y-intercept is c, which is easiest to do as well. We already know that your y-intercept is c. And what is the use of the y-intercept? Is that simply it is at the point where if you're trying to determine what the y-intercept is, it is at x is equal to 0. The line x is equal to 0, which is also the y-axis, that is where your um, x-intercept lies. Oh, y-intercept lies. Apologies. Keeping this in mind, we already know now. This is the slope-intercept form equation. Now we're going to go into a bit more depth with it. Now, how do you find that? How do you use that to form an equation? Next up, what you have is another equation, which is your what you may call this is the general form of the linear equation, and then what you're going to have is the slope point form equation. So this is slope point form equation. Now, for example, if you're given a point and if you're given the slope, which is the gradient, if you're given that and you want to find the equation of the graph, you can easily use this form to find that. And this form states what? That simply you're going to have what you may call y minus y1 is equal to m into x minus x1. So in this point form equation, what you've been provided with is that if there's a question in which you're given the gradient and you're given a point like x1, y1. And if all of that is given, you can utilize this to form the slope point form equation. Is this clear, guys? Any issues with this so far? Like
No, Mister.
very basic stuff. No, Phil, is this clear? All right, no. Now, knowing all of this, I also need to know that how to calculate the length or the distance. Now, you need to know the distance formula for this as well of a linear equation. So, what we're doing is, let's look into the distance, or you can say, you know, length of a line. So, the distance formula states, what does it state? That it's going to be change in x whole squared plus change in y Oops. Plus change in y whole square. Let me whole square it. All right. So if you're trying to calculate the distance of or the length of any line, you're simply going to deal with it by using this formula. And another variation of the same formula can be written like this, like it's you need to calculate change. So what is that going to entail? That simply it is going to be another version of this formula can be under root x2 minus x1 whole squared plus under root y2 minus y1 whole squared. All right. So this is how you calculate the distance from A to B or the length of a line simply. Because how will you do that? It's usually going to be that you will be given 2 points, A and B, and you will ask to calculate the distance. So A is going to have its own respective points. B is going to have its own respective points, which will be, like x2, y2. And you will put those points into your you will put those points into your distance formula, and you're going to get to your calculate the distance between the 2 points or the length between 2 points. Now this is for all for your linear equations. Let's look into your what's the ruling for parallel lines. Now if two linear equations, wait, let me write that down as well. So this is entirely for linear equations. So if you're doing linear equations, your distance of a line and the length of the line is found by that formula. Now moving forward, if two lines are parallel. Now for parallel lines, your nothing really happens apart from the fact that they are showcased using this, like two lines together. This will show that two lines are parallel. So I can write this as this symbol shows that AB is parallel to CD. Clear? This is the symbol for showcasing parallel lines. What is the property for parallel lines? That simply
They have the
they
same slope.
they have the same what?
Slope.
Yep. So they have the same gradient or they have the same slope. So for two lines which are parallel, M1 is going to be equal to M2, which is same or you can call equal slope. And that is like common sense as well. How is it common sense? Let's see. So for example, if I draw two parallel lines, this is a line, I'll duplicate the other one. Now, technically, gradient or slope is what? The angle at which it's bent, right? The angle at which it's bent. So what is going to happen is, but both these angles, both these lines are at that one particular specific angle. Therefore, these lines are going to be what you may call, because they're at the same angle, because they have the same slope, regardless of the fact where they are, regardless of the fact that they are two separate lines, as long as they're parallel, that means that they have the same slope. Therefore, the gradient is equal to each other. Next up, you have what as another property, which is what if two lines are perpendicular? Now, for two lines which are perpendicular, that means that there is a 90-degree angle in between them. So for perpendicular lines, first of all, you need to realize that that means that they have a 90-degree angle in between them and they are showcased. Like if you want to symbolize two lines which are perpendicular, you're going to draw an inverted T. Why? Because this inverted T just showcases that two things have a 90-degree angle. So A is perpendicular to B. I can write it like this. Simply for perpendicular lines, it's in very common terms. We say that the gradient of two perpendicular lines is the negative reciprocal of each other. But if you're looking at the in terms of formula, it's going to be m1 times m2 is equal to -1. And technically, we're talking about what you may call negative reciprocal. The gradient is negative reciprocal of each other. Clear, guys? Any issues with this?
No, Mr. No issues.
No, Phil?
No issues.
Perfect. Now we're going to have, let's just say that, for example, these are your negative reciprocal. So, for example, if the gradient of one line is 2, then if another line is perpendicular to it, its gradient is going to be -1/2. Reciprocal as well as negative reciprocal. Keeping this in mind, let's look at how to calculate the midpoint of a linear equation. So the midpoint of a linear equation is calculated using what it is going to have a midpoint. So your midpoint is, and first of all, a midpoint is usually labeled with a capital M. Kindly make sure that you do not confuse midpoint with gradient. Gradient is lowercase m, midpoint is capital M. Clear, guys? Knowing all of this, what we can do is that we can move forward with the formula to calculate midpoint, which is equal to your what you may call um technically it's just simply taking average of your coordinates. So going to have y1 plus y2 over 2. So and this is going to be equal to x at the midpoint and the y coordinate at the midpoint. Is this clear, guys? That is what sort of like sums up coordinate geometry. A lot of it, most of it you've done before as well. And that sort of sums up linear coordinate geometry. Now, for example, if we look into quadratic equations now. So, first and foremost, whenever we're trying to look into quadratic equations, we're looking forward and seeing what you may call whenever we're trying to look into quadratic equation, the first thing that I need is the general form of the quadratic equation. So it's going to be that the general form of the quadratic equation is, just give me a moment. I'm like really lazy. So, or I'm really smart. So the general form of a quadratic equation is y is equal to ax squared plus minus ax squared plus minus bx plus minus c. That's your general form of a quadratic equation.
So wouldn't C always be positive? because
No.
even if you square a negative number, it would always be positive.
But why are you squaring C?
It's like, Mr. For quadratic equations, it's a squared plus 2ab plus
No, no,
b.
no. That's you're taking into factorization. This is the general form of a quadratic equation where C is I get what you're saying. I think you're deriving it from this cursor. So A plus minus B whole squared. That is factorization of any quadratic equation. All right, where it's always plus B squared. Clear? That is different from the general form of the quadratic equation. Your general form of the quadratic equation, in this general form, your C is again your y-intercept. So your y-intercept can be negative.
Right.
All right. And similarly, the coefficient of A is going to determine like a positive. A is going to be an upward opening graph, and a negative sort of like A value of A is going to be a downward sloping graph. Sort of like a smile and a frown for upward and downward slope. Clear, boys? Anything that you guys don't get from this so far?
No, sir, I get
No.
that.
Perfect. Now, this is the general form of a quadratic equation, or you can say, actually, this is a general form of a quadratic curve, you should say. My bad. Now, if you want to find the x-intercepts, for finding out the x-intercepts, what is going to be the case? That, whenever you have to find the x-intercepts of the quadratic equation, you're simply going to this one, the yellow x-intercepts. Then simply what you're going to do is that you're going to write down, you're going to take y is equal to 0, and you're simply going to put it in your general form of the equation, which is going to turn into ax squared plus minus bx plus minus c is equal to 0. Then what you're going to do is that then you're going to simply use your quadratic formula, which is equal to what? That x is equal to minus b plus minus under root b square minus 4ac over what you may call 2a. And whatever two values of x you're going to get, like for example, through this, you're going to get either x1 or x2. These are going to be your x-intercepts. Clear, guys? So in order to calculate your x-intercepts, you're going to use y. You're going to put y is equal to 0, because the x-intercepts are going to be, on the x-axis where the y is, already equal to 0. So at the x-axis where y is already equal to 0. Clear? Knowing all of this, we also know how to find the turning point. All right. We also know how to find the turning point where did we do turning point? Yes, when we did quadratics. So if you use completing the square form, you can even, find out your turning points of your curve as well. So for example, it's going to be so that, let's just say that if I want to find my turning point, for it. My turning point. Now, again, I'm not going to go into detail regarding turning points and gradients because of the fact that we're going to do them all over again in differentiation as well. So turning point or your minimum maximum point, or you can say even your stationary point. They're all the same. That is, you know, you can simply use completed the square form, which is going to be y is equal to, sometimes there's an a outside, could be so x plus minus h whole squared plus minus k. This was the completed the square form, and from here you're going to get minus h and k. Why do I write minus h all over again? Because whatever um value of h is going to be inside the bracket, when you go to the opposite side, it's going to have an opposite effect. Like the sign is going to be reversed. So if you have x plus h, when you find out your turning point, it's going to be x minus. H is going to be minus. All right. So it's the inverse of whatever's happening. So if it's x plus 2 over here, the coordinates of the turning points are going to be minus 2. And k is going to remain as k. All right, guys. This is also done. And now we also know that, using how do you calculate the gradient? Is that you use what you may call, hmm, for example, in order to calculate the gradient, we have two methods. One is not going to be used in your syllabus, tangents, and but you still need to know. So you can calculate the gradient via tangent and differentiation, which obviously is a major part of our syllabus. So we're going to come back to it soon as well. Now, knowing all of this, is this clear, guys? Any issues with this? This is just the basics of coordinate geometry.
Yeah, I
Now,
got.
all right. No, for any questions?
No, sir.
Now, a small topic, or you can say subtopic, is circular measure in among coordinate geometry. That is what we're going to focus on now. The above part was easy as you like. So this is going to be circular measure. For circular measure, what's going to happen is that, for example, when we're doing circular measure, we need to first know the general form of the equation of a circle. So we want what is the general form of the equation of the circle. So general form of the circle equation. So we're going to have the general form of the circle equation. Can anyone tell me what is that?
Um,
Yes, Parsha.
it's x plus
Hmm.
uh
Minus.
x minus a squared plus y minus b squared equals r squared.
Perfect. All
And
right.
AB is basically the center of the circle.
Well done. So you're absolutely right. The general form of the circle equation or the equation of the circle is x minus a whole squared plus y minus b whole squared is equal to r squared. Whereas a in comma b is your circle center. So this is your circle center, and r is obviously your radius for the circle. So it's going to be circle center. Clear the coordinates of the circle centers, and that is. Knowing this, keeping this in mind, I think this is the x coordinate, the y coordinate. Keeping this in mind, now what we're going to do is that, and also r is your radius. Now, mind you, whatever is written inside the circle equation, if it says x minus a, that means that your circle center is actually positive a. The x coordinate of your circle center is a positive. Just as I told you before, guys, whenever you go inside the bracket and it's being whole squared, you have an opposite effect outside. So, for example, minus a minus b, x minus a and y minus b of the circle center, they're actually if you find out the coordinates of the circle center, it's going to be A and B, positive A and positive B, even though it's clearly stated in the circle equation that it's minus. So the circle equation is always going to remain minus. All right. So for example, if your circle equation is written as A plus 2, x plus 2 whole square, that means that your circle center must be minus 2. Why? Because your equation is always minus A. So if your a is equal to minus 2, then that means that x is plus 2 in the final equation. Otherwise, it is always going to be minus. And also, r is your radius. Is this clear, guys? Any issues at all with this?
No, sir, no issues.
Perfect. This is what you know. This is how you're going to use your circle equation, where it's going to be, just give me. So, for example, what's going to happen is that this is the general form of your circle equation where your radius is squared. Keep this in mind, please. That your radius is squared and there's a negative sign used over here. All right. Any issues with this? Now, we can even, we do have less time, but okay, let's, complete this in the next class. We'll try to complete this in the next class. I have really less time now. All right, boys. So, keeping this in mind, I'll see you guys on next Thursday. All right.
And
You smiling, guys. Allah Hafiz. Bye
thank you.
bye.
Allah Hafiz.
Bye, sir. Take care.
Thank you.